Hello. So we have discussed the ratio. We say the two people, if one earn $1, then other one also make $1. Or if first one make $5, the second one make the $5. So we say there's two guys make the same money. So we can use the ratio like okay, y over x, the ratio is 1 to 1. Okay. So if one guy make $1, then other guy make $3, or if I make if you make $1, I make $3, right? So we say so suppose I just said this now, y make more money than x, so we say y make 3 times of money as x. So if you make $1, I make $3, right? So we write this relationship is y, here y is equal x, y and x same, and this one is y equals 3x. If you make 1, I make 3. If you make 2, I make 6, right? So y is 3 times of x. So in mathematics, we call those relationships as function. Okay. So sometimes, so we need graph those functions. We need to use a graph like, okay, so we put a graph on a rectangle coordinate. So here we have x and y. We have two variables. So we use this like rectangle coordinate. So this x-axis, y-axis. So for this point, like x equal 2, y is 3. So there's a point. There's a point. So we denote this coordinate is 2 and 3. Right? So x is 2, y equals 3. And so this one, let's say like for this one, so x is negative 3, y is 1. And this point x is negative 1.5, y is negative 1.5. Okay? So this like rectangle coordinate. So we put this graph for y equal x and y equals 3x on the like rectangle coordinate. So y equal x is we just pick y, x is 1, x equals 0, y 0, x 1, y 1. So x 2, y 2, x 3, y 3, like this. So we get this line. So this line, we denote this line, equation for this line is y equal x. So the other line is opposite, like x equal negative 1, like x equal 1, y equal negative 1. X equal 2, y equal negative 2. X equal 3, y equal negative 3. So this line is, this y is negative x. Okay. So for y equals 3x or 4x same. So like, okay, x equals 0, y 0. X equals 1, y 3. X equals 2, like here. X equals 2, y becomes 6. X equals 3, y equals 9. Right? So we got, so we did the connect those points. So we have this line. Okay, so we call those lines as a linear function. So a little bit more general, linear functions y equal mx plus b. Like this one, y equal x minus 3. So the line for this line, so we say, we just pick some point of x equal, let's say x equals 3, y equals 0, right? So there's a point. 3, 0. So x equal 5, y equal 2, so there's a point. And then there's a point, there's a point. Okay, so we get this line. So this is line for this equation y equal x minus 3. So for this line, we have there's two typical points. This, like this line, the intercept with y-axis or with x-axis. So we call those two points as this point as a y-intercept. Like, so y-intercept, so here this point is x0, y equals 3. And this point, the x-intercept. So in x-intercept, the y is 0, right? So y equals 0, x equals 3. Okay, so for this line, so we have x-intercept. So in general, so what is intercept? X-intercept or y-intercept is just this line. If the okay, so this is y-intercept, this is x-intercept. Okay. So for this general function y equal m, y equal m x plus b. So we give m or b a name. So we call m slope. And this y is, this b is y-intercept. So y-intercept, we know y-intercept when x, there's a point, y-intercept. When x equals 0, the y value, like y-intercept. So here we can say when x equals 0, y equal b. So we just call this y, this b as y-intercept. Okay. So for two lines, so there we can check all cases for two lines. So the two lines could be like, oh, so it's two lines. So we say they have intercept, right? So sometimes we need to find this intercept. So sometimes there's two lines parallel, like there's no intercept. And so a typical situation, the two lines are perpendicular. So like if this line thus, this line thus, and their intercept is non-diagonally, so we call this as perpendicular. So if for the two line, if we wanted to find the intercept, so we can find what this point is. So what the intercept is. So at this point, this y and this both y the same. So we just solve this equation. We just let 2x this y equal this y. So we solve this equation. So here we don't like this half, don't like this 1, 2. So we multiply 2. So we change this as 4x minus 2 multiply 2, right, equal x plus 2. Okay, so then we move x here, 3x equal 4. So x equals this. X equal 4 over 3. Then when x equals 4 over 3, so what's the y value? So y we just plug in here. Y equal 2x minus 1, or just half x plus 1. So same, either way is okay. So 2x x thus minus 1. So this equal 3. So this is 2. So here's 2 multiply. Yeah, not 2 and 4 over 3. 2 multiply. So this equal 3, 8 minus 1. So 1 is 3. So that's equal 5 over 3. So this point is x is 4 over 3, y is 5 over 3. So this is intercept. Okay, so for parallel lines, there are no intercept. So we want to check like what is the condition for parallel. Like we find these 3 lines are parallel. So we find that the coefficient for x is the same. So this is y equal 2x minus 3 or 2x minus plus 1 or 2x plus 5. So the 3 lines are parallel. So from here we can say if 2 lines are parallel, then the conditions, the slopes are equal. Okay, so we say, so and the 2 lines like, okay, so y equals 3x minus 1 or y equal, so 3x plus 2. So those 2 lines are parallel, right? Okay, so for perpendicular we find this example for we find if this is 3x minus 1, that is 1 over 3x minus 2. Then the perpendicular. So here we only focus on the slope. So in general, we say there's 2 lines are perpendicular. The condition is the multiplication slope, the multiplication m1 multiplied m2 should be equal -1. Or just a little simple. Here is 3, then 1 over 3, but here -3. Okay, negative. So let's say that if m1 m2 multiply equal 1, so we can say these 2 numbers are reciprocal, right? 2 and a half, 3 and 1 over 3. But here is negative. We say negative, -1. Okay, so let's say like so if there's 2x, then this one should be -12x. So this line and this 2 lines are perpendicular. Okay, so as a function, we let this y equal mx plus b. So y related to x. And here sometimes we call x as independent variable, and y is dependent variable because y depend on x. But sometimes we can consider general situation. We say we just change this y, we just change this y equal y is mx plus b. We just change this as like this, y minus mx equal b. Or we put x first, y second. So in general, so we just say change this as ax plus by equals c, equals some constant. Okay, so we call this is a more general form. Like here, y minus mx equal b, we can change this as negative mx plus 1y equal b, right? So if we use general form, then there's 2 lines are parallel is the coefficient AB is same. Ax plus by equals c1 and ax plus by equals c2. Those 2 lines are parallel. So perpendicular is just changing the AB to BA. But we should put a negative somewhere. Ax plus by equals c, or bx minus ay equals d is perpendicular. Or ax, we can put a negative We also can put a negative here. X plus by equals C. Then like we can put the bx plus ay. Yeah, we also can put a negative for b, like equal some number equal d. Okay, so let's say so for this one, 3x x minus 3y equal negative 9, or x minus 3y equal 4. So the two lines are parallel. Okay. So sometimes we want to find the equation from one line to other line. Like here, let's check this problem. We want to find the equation of the line that goes through this point and is perpendicular to this line. So perpendicular to this line, so we can change those equation, we just change 2 and 3. So this just becomes 3x 2y. So here's only the negative, so we just put a positive. So equal some number. So this line should be like this: 3x plus 2y equals some number. So we just needed to determine this number. So we know this line goes through this point. So we just plug it in. So x equal 1, y equal negative 2. So x equal 1, 3 times 1 plus 2y equal negative 2. So we find this number equal 3 minus 4 equal negative 1. Okay, so we know this line, the equation, so we say answer. The equation for this line is 3x plus 2y equal negative 1. Okay. Okay, so we have many relationships. They are linear relationship. So the ratio is a typical situation, right? Like if you make $1, I will make $3, right? So if you make more, I will make more. So in a little bit more general is like you really like work longer, you can make more money, right? So let's check a typical example. Like your wage is determined by your baseline, base salary plus your commission. If you let's say some company just pay you money like this way, okay. So let's say your salary, we say base salary, I will give you 150 1 week plus 5% commission of your sale. So 5% commission means if you sell $100, you can get $5 as a commission. If you sell $1,000, then you can get $50 as a commission, right? That's 5%. Okay, so now the question is, so your sales is so much, like 1,800. So 105, 1,800 is how much? So 18 multiplied 5, right? 18 multiplied 5 is $90, right? So you can get $90 as your commission. So how much you can earn? So you can earn your base salary. We say I'll give you your wage. We say your wage is determined this way. Okay, $150 plus 90, right? 90 is from commission. So you can get 240. Okay. So from here we can produce some many some other equation. If we know this, we can determine others. So let's check the similar problem. Like okay, so this time is your base salary. So here we're talking about monthly salary. So base salary is this plus 8% of commission. So 1 month you wage is this 2760. So this 2760 come from two parts: your base salary, right, plus your commission. So this means your commission is 760, right? Okay. So the question is, what is your sales? The amount of sales. Okay. So let's say, so like if you wanted to get so much, how much? So what is sale you have to make? So your commission is 8%. So let's say 1,000, no 100, you get $8, right? As your commission. So, but this month you get so much. Then we want to find it. What is your sale? How much you sell? So 108. So we just check from here to here. Like 760 is equal how much of 8? So 760. We just divide by 8. So 760, we can say this equal 95 times 8. Okay. So this $8 means 100. So here means 9,500, right? So that's your sales. Okay. So this is today's topic. Today's topic is linear relationship. So we can use graph to stand for linear relationship, like y and x. And we also have some real world examples for linear relationship. Like you work more, you can make more money. So this is a typical example for linear relationship, right? Okay, so we can stop here.